Hi everybody, Patrick here from EngineeringShock.com, PaintballProps.com, and EscapeRoomElectronics.com. So this is project video number 2 for the Arduino Playbot. If you haven't already seen the Kickstarter campaign, it is linked below. So let me preface this by saying this is one of 3 clap projects. This is the most basic clap project. I'm going to be doing the next 2 videos in series, so they all get a bit more complicated. We are going to talk about the microphone circuit and the relay circuit in just a moment, and then once I've given you a demonstration, we're going to hook it up to an AC lamp, and we're going to be able to clap on, clap off our lamp. So first of all, what we have to do is we have to turn on our LCD, but we're going to turn the LCD backlight software pin off for this video. So we want to connect switches 2, 3, 4, 5, 6, and 7 on. And that will consume GPIOs 4 through 9 on our Atmega 328PU. GPIOs 4 through 9 connect to the LCD. The LCD is talked about more in the first video. Second of all, we're going to force our LCD backlight on by jumping the EN header right to the left of the dip switch. Thirdly, what we're going to do is we're going to select mic. There is a 3-pin header here labeled LDR/mic. If we short the left 2 pins, we're selecting the light dependent resistor, which we're not going to do for the specific video. What we're going to do is we're going to select the right 2 pins, the middle and right pin. And so now we have connected our microphone circuit to the A3 analog pin input. So now let's plug it in and I'll give you a basic demonstration of the software before we talk about the schematics. Now the LCD looks great to the human eye. It might be a little hard to pick up what it says because of the lighting, but I'll read what it says to you anyway. So I'm going to plug it in. Wait for clap. So what I'm going to do now is I'm going to clap. Clap detected, relay on. I'll clap again. Clap detected, relay off. So for this software, we're actually using a fixed window for sensitivity. You can change that window. If you pledge towards a Kickstarter campaign, all of these project videos will be available for you along with all of the commented software for each of the videos. So I'm going to clap on again. Clap detected, relay on. Clap again. Clap detected, relay off. So it's a very simple project. Now let's talk about the microphone circuit and the relay circuit. This circuit shows both the light-dependent resistor circuit and the microphone circuit. We're not going to talk about the LDR, light-dependent resistor circuit, right now. We're only going to talk about the microphone circuit. We'll refer back to this diagram in later lessons when we start work with our light-dependent resistor. In any case, what we got here is we've got R12, which is a 10K ohm resistor, in series with an electret microphone, or rather the positive pin of the electret microphone. The negative pin of the electret microphone is connected to the ground line. Between the microphone and the 10K ohm resistor, we've got connected to pin 1 of our 3-pin jumper. Pin 2 is connected to a 0.1 microfarad ceramic capacitor. This acts as a coupling capacitor. It blocks DC, but when the microphone senses noise, it couples across that AC tone. And we've got a pull-down resistor, which also acts as a little bit of a filter, but we're not using it with that intention. But that pull-down resistor ensures that the A3 analog pin on the Arduino Uno, or rather on the Atmega 328PU chip, sees 0 volts when there's no noise. Only when the microphone detects noise will AC signals be coupled across that, and we'll be able to sense that with the A3 analog pin. The relay is what we're going to use to control higher power devices. In this video, a lamp. GPIO 11 on the Atmega 328PU controls the relay. Through a dip switch, you have to turn on the dip switch, the relay switch on the 3-pin dip switch, to connect GPIO pin 11 to the protective 10K ohm resistor R11, which is fed to the base of a 2N2222 NPN transistor. Now this transistor is going to act as a switch. It's going to apply power through the relay. Now the relay coil is just above the 2N2222 NPN transistor, and this is just a standard coil of wire which acts as an electromagnet. When 5 volts travels through that coil, through the transistor to ground. When 5 volts is applied through the 10k ohm resistor, the relay will turn on. So when no power is being applied through R14 to the base of the transistor is not conducting power. But when it is turned on, 5 volts travels from the VCC line through the coil of wire, through the collector of the transistor, and to ground at the emitter of the transistor. D1 is a 1N00 or 1N4001 diode, and we have the negative or cathode connected to the 5 volt line, and the positive or anode connected to the secondary side of the coil and collector of the transistor. And this acts as a shunt, because when a coil of wire, or when a electromagnet, collapses, just like an inductor, it causes a spike on the voltage line, which could exceed 5 volts, which would hurt the rest of our circuitry. So what this diode does is it ensures that that spike is absorbed, and so we'll only see 5 volts on the VCC line. It's a very necessary component. So let's talk about the isolated switch. We control the relay electronically, but there are 3 pins of the relay which we'll be using to connect to our AC power source and our lamp. And those are the NO, CO, and NC lines. CO is common. Common is either connected to NO or NC, depending on the state of the relay. When the relay is off, the common pin is connected internally to NC, which is normally closed. When the relay turns on, the CO, common, disconnects from NC and connects to NO. NO is normally open. So what we're going to do is we're going to cut the hot line of an extension cord, and we're just going to cut the hot line. We're going to separate a little bit of the plastic from the conductors. We're going to plug in one of those separated lines to NO and the other to common. So when the relay turns on, the path to that severed wire is reconnected internally within the relay. Here is the 3-pin dip switch. I've got the relay switched to the on position. So now the GPIO is now controlling the relay. Here are the 3 relay terminals: NO, normally open, CO, common, and NC, normally closed. So now what I'm going to do is I'm going to connect my extension cord. What I have here is a dollar store extension cord. And what I've done is I've severed the hot wire and have left the neutral wire alone. So before I did any modifications to this, these 2 wires were connected with insulation. So I've severed this wire, cut it in half, stripped away some insulation. And what I'm going to do is I'm going to connect one pin to the NO pin, the normally open pin, and the other to the common pin of the relay. So when the relay turns on, it acts to short those together, providing power from point A to point B, which will be our lamp. We clap on again, it turns the relay off, severing those 2 wires. Now that they're connected, I want to mention very specifically that this area of the board is now unsafe to touch. Do not go anywhere near it with your hands. Also, you want to make sure that there's a little copper showing as humanly possible. Try to make it so that when you strip your wires, that there's absolutely no copper showing. Now what I'm going to do is I'm going to plug my lamp to the female terminals of my extension cord, and I'm going to connect the male into the AC into an extension cord, and I'm going to plug that into the wall. I'm also going to plug in my 9-volt 1-amp adapter to power the Arduino Playbot. So the lamp is turned on. Obviously it's not turned on because it's connected through the relay, and I've got power applied through the extension cord to the lamp. My AC to DC wall adapter connected to the power supply of the Playbot, and I'll turn on power. I'll clap again. It says, the LCD says wait for clap. Clap detected, relay off. Clap detected, relay on. Clap detected, relay off. So it's that simple. This is a very simple program. The next video I'm going to be talking about the variable resistor and how we're going to use the variable resistor to select 10 different levels of sensitivity. Right now we've only got one level of sensitivity that's fixed in software. Using that variable resistor we can make the clap the clap module very sensitive or not sensitive at all. And after that, we're going to be using all we've learned after this video, the next video, and the next video to create a sensitivity determined or sensitivity adjustable double clap on, double clap off relay module or clap module. So thank you for watching. I hope that if you've pledged towards a Kickstarter campaign that you found this video helpful. If you have pledged at the end of this campaign, you will receive all of the commented code for all of the electronic projects. Thanks for watching, everyone.